When I'm going to restore a vintage radio or piece of equipment, whether it's a Heathkit or a broadcast band radio, etc., I thought I'd mention the things that I look for upon first initial inspection and point out to a few folks the things I see. So this is a Heathkit condenser checker, model C-3. And I've already gone through the unit and done all the troubleshooting and testing. I know what it needs. The unit works. It's way out of calibration because it needs replacement of components. But anyway, when I first received this from a seller on eBay, I immediately realized I got very lucky because the unit is in exceedingly good condition. I'm going to tip the front panel up. And here's the things I look for on the front panel first. I'm gonna pause this and zoom you in. Okay, sorry for the glare. My lighting is a challenge always. So the first thing I look for is not the condition of the paint, but the condition of the lettering. For me, that's the most important thing, and for me, the hardest thing to restore. You know how people will grab a knob and rotate it back and forth, and your fingernail will dig a trace in the front panel and wear away the lettering? None of that is present here. There is no rust. There are no wear marks. The front panel is in pristine condition. I got lucky. I'm going to try to talk faster and make that move along here. I babble. The condition of that side panel is wonderful. The condition of that side panel, similarly excellent. The rear panel, very, very, very nice condition. So I've got the two screws out that hold the cabinet together. I'm going to pause you and bring you back after I slide the rear off. Hang on. I lied again. Before I do that, I wanted to show something. I haven't removed all of these knobs. I removed one just now because I want to show something. These knobs that Heathkit uses are very prone to cracking and failure. Hang on, I'm going to set that down, tilt you up. These three webs in that knob will crack apart, and when that happens, this round part cracks apart and the knob will no longer grip the shaft. And the reason why that happens is A, age, and B, these wafer switches can get stickier and stickier with age and become harder and harder to turn. And also, oftentimes these wafer switches the tension is way too high. In another video, I'm going to show the best way I've found to repair cracked knobs and make them far stronger than original. And I'm also in the same video, going to show how to adjust the tension on the wafer switches. Okay, I'm going to pause you again and take the rear panel off. I have no idea when this unit was last opened, but this is the amount of dust in the bottom. Almost none. I'm going to pause you and reposition things. Okay, so when I popped the rear cover off this unit, I knew again that I got lucky. Here are the things that I see when I look at any vintage piece of equipment. My eyes first will fall upon the chassis. How much rust? How much dust? Is there an oily film on it? Oftentimes there is. And oftentimes that oily film is what protects the steel chassis from corrosion. That's what I'm looking for first, corrosion. And especially on transformer cores. Now this one, you can't see the exposed E&I laminations, right? They're covered by this cover. But looking inside here, the varnish looks new. It's present. It's not flaked off. There's no signs of rust anywhere on it. I'll look in the end of the transformer core. Yeah, you can't see. Yeah, the lighting is not adequate. But I'll look in the end of that core and to see the condition. Does it look like it's been overheated? You know, I'll look at the color of the protective tape over the paper over the core. Is it brittle? Is it cracking apart? This is not. How flexible are the wires? One moment. I take an overall look at the top side of the unit, at the components. How many of them have been replaced is what I'm interested in. I'll also look at the vacuum tubes. Are they the OEM manufacturer? Are they the right ones? You know, gives you it's an indication of how many hours of service are on this unit. In this simple unit's case, this is a precision cap used for calibration of the unit, as is this 200 picofarads, 2.01s in parallel. I'm not going to mention what parts are bad in this unit. That's not the intent of this video. My next, and then on any Heathkit, the next thing I've got to take a look at, and I don't know if I can, I'm going to reposition things here. The wafer switches. I will closely visually inspect each and every contact on each and every wafer of each and every wafer switch, and for very good reason. Now, I don't think you can probably tell, but where that switch, for example, that contact right there, when that switch rotates underneath that contact, if things are amiss, you can destroy that contact. It'll bend it all, tweak it all out of shape, and when you try to bend it back, it just breaks off, ruining the switch and possibly the unit. So very, very cautiously at this time will I rotate the switch. You can't see my, right? Very cautiously rotate the switch whilst looking at each contact as it comes into play. It should gently rise as the tab goes through the contact. You should see the contact gently spread apart. If that doesn't happen, stop rotating the switch. If it does happen, continue on. And at this point, I will flip the unit over and basically do the same kind of visual inspection on the bottom. Hang on. Okay, on the bottom, the same type of inspection. Is there rust, corrosion? I will visually inspect the electrolytic caps to see if they look dangerous. And there's a reason for that, because I'm going to energize my unit slowly in a controlled fashion using a variac and an inline, either a dim bulb or a current meter, so that I can continue troubleshooting before I order parts for the unit. I don't want to just buy the obvious parts and then get into it only to find that I need more that I don't have on hand. So the first thing I'll do, check the visual inspection. I'll just look and see how many wax and paper caps am I going to have to buy. How buried are they? Sometimes it can be miserable on an All-American 5 AM radio. Ooh, some of those tabletop radios have the parts jam-packed. but they've got to go. Every one of them. Every wax and paper cap has to go. Every electrolytic has to go. The micas are generally fine, and that's why I bought the C-3 condenser tester. They're generally fine. 95% of the time, the mica caps are fine, but that leaves the other 5% that'll cause you misery if they're bad and you don't replace them. you know. So, visual inspection, wire condition. Is any of the wire, you see this especially on an All-American 5 AM tabletop radio. There was a period of time when they got away from the cloth-covered wire and went to a low-grade rubber. And some colors of that rubber wire, I think it's the red and blue especially, oh man, they just crumble away, leaving a bare conductor. So that's what my visual inspection includes, the wire, condition, and type. This unit only has cloth-covered wire on the transformer, and they're fuzzy. They have the white fuzz, but they're in excellent condition. A little stiff, not terrible. Stiffness of wire doesn't bother me. They'll never move again. That does not bother me. There are some who will coat them with lacquer or enamel to lock the cloth in place. I'm not going that far, but anyway, to carry on. How many of these molded capacitors are there? I've already tested that one. Okay, it's fine, but it's got to go. They like to fail. And again, this one down here, well, that's in series with your test lead that you connect to your capacitor. You don't want that cap to fail. It's getting replaced. Anything that might impact safety gets replaced. In this particular unit, I tested the electrolytic capacitors with a simple ohm meter, and that's all it took to show that they were exceedingly leaky. Those electrolytics being these. They were exceedingly leaky, and I couldn't safely energize the unit for further testing, so out they came. Those are 8 microfarad units. These are 22 at 450 volts. The normal operating voltage of this one is 410. Well, my cap is only 450 volt rating. And with modern 120 volt line voltages, it was running about 460 volts. So what I did was, this is a 410 volt line. This is a 150 volts, typically. So, and they were both way high, given that I increased the value from 8 to 22 microfarads, and it's operating on 120 volts AC. So all I had to do to bring that situation under control, I could have, well, even if I would have installed 8 microfarad caps there, given that I'm operating it on 120 volts, I don't have to. I have a variac, but it won't be operated on a variac. It needs to be able to operate on 120 volt AC. So what I did was I put a swamping bleeder resistor on each cap. This one's about 150K, this one's about 100K, and that brought the voltages right in line with what the specs call for. And not only doing that, it aids in safety because these bleeder resistors will quickly bleed off the voltages on these caps. In under 30 seconds, they're down to under a volt. So, and it also aids in stability regulation. Well, there is no regulation. It aids in stability. And it also, these swamping resistors will greatly aid in longevity of the filter caps. So having said that, I was able to safely energize the unit, and that's where it stands now. I'm ready to order parts for this. But I'm also going to get into a couple of my Heathkit ham radio units. I think I'll troubleshoot my DX-60 and my HR10B receivers. I'll do the troubleshooting and assessment on those, and then I'll order the parts for all 3 units. So, one moment. Oh, I might mention also, another thing I assess, tightness of hardware, like where these terminal strips are, and which usually depend on the mounting for a ground connection. I assess the quality of the solder joints, especially on a Heathkit, but on any vintage piece of equipment, because Lord knows how many hands have been in there before yours, you know. And so another thing I look for, anything scary, any bare wires coming close to each other, you know, and these old vintage pieces of point-to-point wiring, man, there's lots of bare wire all over the place. And that's fine. Any of it too close to each other. So another wafer switch down here to clean and assess. And in the video that I show on wafer switches, maybe I'll just do a video on wafer switches and knobs. How to clean them, how to lube them, how not to lube them, how to adjust the rotational tension, the torque required to turn the switch. There you go, sound like a weirdo again. Hang on. Kind of hard for you to see, but back up top again. It's sometimes hard to tell how many hours of operation a unit has. Has it sat on a shelf most of its life? Or has it sat there been playing radio, you know? One way you can kind of tell is if you can ascertain that this tube is the original one, look at the filament evaporation on the glass envelope above the filament, right? You'll get a dark spot. It'll get darker and darker with age. And this one has a bit. It has a bit. More than I'd have thought, given that it's a condenser checker. Makes me wonder if this thing sat on a technician's bench turned on 8 hours a day. Probably not. Probably not. Anyway, those are the things I look for when I'm about to restore a piece of vintage test equipment or a piece of ham radio equipment or an AM radio. I don't do FM, don't have the gear. I'm just, in this case, overjoyed that the lettering is in beautiful condition, and the paint on the lunchbox style cabinet, very, very, very acceptable. Very dirty, but very acceptable. Hopefully this is of interest to somebody. After this has been restored, as with each of my units, I'm going to do a pre-restoration assessment with each Heathkit ham radio unit that I have on the shelf, waiting. And I'll do a quick, not like this one because I did a lot of explanation in this one, but in those, it'll be a quick, this is what I see. Heathkit HW16 pre-restoration assessment, for example. Anyway, those won't be as long as drawn out as this one, I hope. 73, take care and be well, please.